Hello there, and welcome to Deep Earth Stories. Get comfortable, turn the lights down if you can. Because what we are about to explore together has been waiting a very, very long time for someone to listen. But before that, tell me in comments where are you listening from and what time is there right now, and please subscribe to my channel. Tonight, let's go somewhere very few people have ever been. Not because the journey is dangerous, not because you need special equipment or years of training. Tonight, you can travel there simply by closing your eyes and letting your breathing slow down. You can go there from your bed, from your couch, from wherever you are right now, wrapped in whatever warmth you've pulled around yourself at the end of this long day. Maybe the lights are already dim where you are. Maybe you've set your phone down beside you, or you're holding it loosely in one hand while your eyes grow heavier. Maybe outside your window there is the sound of wind or rain, or the quiet hum of a city that never fully sleeps. Whatever is out there, you don't need to follow it tonight. You can let it go. Tonight, we're going somewhere else entirely. We're going south, far south, past every country you know, past every warm ocean, past every familiar shoreline. We're going all the way to the bottom of the world, where the maps run out and the ice begins, where the wind has been blowing for longer than any human civilization has existed, where the snow falls on mountains that no living person has ever climbed or named. We are going to Antarctica. And I want to tell you something before we begin. This place, this enormous frozen continent at the very end of the Earth, is not just ice and cold. It is not just penguins and polar expeditions. It is one of the greatest mysteries our planet holds. Beneath those miles of ice, beneath the frozen silence, there are things that will gently astonish you. There are lakes that haven't seen sunlight in millions of years. There are mountains taller than the Alps, completely hidden under white. There are ancient air bubbles trapped in ice that carry the actual breath of a world that existed long before the first human ever looked up at the sky. And there is something else too, something quieter and harder to name. A feeling, when you learn about this place, that the world is much older and much stranger than we usually remember. That we are very small, and that this is somehow a comforting thing, not a frightening one. So if your eyes feel heavy, that is okay. If you want to close them right now and just listen, that is exactly what this is for. You don't need to memorize anything. You don't need to stay awake for any of it. This story will still carry you somewhere peaceful, even if you only catch pieces of it between soft, slow breaths. Just get comfortable. Let your shoulders drop a little. Let your jaw relax. Feel the weight of the blanket or the pillow beneath your head. Notice how still your body is already becoming. We have all night, and the ice has been waiting for a very long time. For a moment, just breathe. There is a question I want to ask you before we go any further. It is a simple question, and you don't need to answer it. Just let it settle in your mind the way a leaf settles on still water. What if there is a whole world beneath the ice that no one has ever seen? Not a made-up world, not a fantasy, a real one. A geological, biological, scientific world that has been locked away under kilometers of frozen water for millions of years, quietly existing, slowly changing, completely untouched by human hands or human eyes. What does it feel like to hold that thought? For me, it feels like standing at the edge of something vast and dark and deeply, deeply quiet. Not a scary kind of dark, more like the feeling you get when you look up at a sky full of stars and realize, without panic, that the universe does not have an edge you can point to. A gentle vertigo, a soft amazement. Antarctica holds more secrets than almost anywhere else on Earth, and the remarkable thing is that we have known about this continent for barely 200 years. The first humans to even see it did so in 1820. Think about that for a moment. This is the 5th largest continent on our planet. It is larger than Europe, it is larger than Australia, and we only found it 2 centuries ago. Before that, people guessed it was there. Ancient Greek philosophers thought there must be a large landmass at the bottom of the world to balance the land at the top. They called it Terra Australis Incognita, the unknown southern land. For thousands of years it existed only as an idea, a mathematical ghost, a continent that logic suggested must be real, but that no eye had ever confirmed. And then, in the cold January of 1820, a small group of ships sailed farther south than any ship had dared to go. And through the fog and the spray and the impossible cold, the crew saw ice cliffs rising out of the sea. They had found it. The ghost continent was real. But here is the strange and beautiful part of this story. Even after we found Antarctica, we barely understood what we were looking at. Because what we saw was ice. Miles and miles and miles of ice. And what the ice was hiding, what lay beneath it, would take another 100 years to even begin to understand. Let's drift a little further into this. Imagine you are standing on a vast white plain. There is no landmark anywhere you can see. No tree, no hill, no building, no road. Just white in every direction, stretching to the horizon, which is also white. And above it a sky that is a cold, pale blue. The sun is low, as it always is here, skimming along the edge of the world without ever setting, because in the Antarctic summer the sun doesn't set at all. It just circles slowly, like a lantern hung at a tilt, casting long flat shadows across the snow. The air is so cold it feels sharp, like breathing in metal. But it is also the cleanest air on Earth. Scientists have measured it. There is almost nothing in it. No pollen, no pollution, no dust from distant cities, no trace of the million small particles that fill the air of every inhabited place. It is pure in a way that is almost impossible to describe. Some people who have been to Antarctica say the air there feels like drinking cold water, except you're breathing it. The wind makes a sound here unlike any wind you have heard. It doesn't howl exactly. On the worst days it screams, but on the quiet days, which do exist, it makes a kind of low continuous murmur, like a note held for a very long time on a very deep instrument. Some of the people who have spent months at Antarctic research stations say that after a while you stop hearing it as wind. It becomes a kind of presence, a voice that has been speaking since long before you arrived and will keep speaking long after you're gone. This is the surface of Antarctica. And already you might feel there is something sacred about it, something that does not want to be disturbed. Now, let me tell you about the ice itself, because the ice is not simple. It is not like the ice in your freezer, or the ice on a frozen lake, or even the ice of an Arctic glacier. The ice of Antarctica is its own thing entirely. In some places, the ice sheet is nearly 5 kilometers thick. 5 kilometers. Think about what that means for a moment. If you could stand at the bottom of that ice, on the actual rocky ground of the continent and look straight up, the surface would be higher above you than the cruising altitude of a commercial airplane. You would be at the bottom of a frozen sky. This ice did not form all at once. It built up over millions of years, layer by layer, snowflake by snowflake. Each winter, new snow fell and compressed the snow beneath it, and over thousands of years the weight turned the lower layers into ice so dense and so blue that it barely looks like frozen water anymore. It looks almost like glass, like a window into geological time, and this is where something extraordinary happens. As the snow falls each year and is slowly compressed into ice, it traps small bubbles of air, tiny pockets of the atmosphere, exactly as it was at the moment the snow fell. These bubbles are preserved, perfectly sealed, for hundreds of thousands of years. When scientists drill down into the ice and extract long cylinders of it called ice cores, they can actually open those ancient air bubbles and breathe in, or at least analyse, the air from a world that existed 800,000 years ago. They have found the air from before any human civilization, from before farming, from before language, from before the first stone tools. They have found the air that blew across a world where woolly mammoths walked through snowy plains, where saber-toothed cats stalked through forests that no longer exist, where early humans were still learning what fire could do. And deeper still, the ice holds records of climates that no human has ever experienced. Periods when the Earth was much warmer than it is now, periods when it was much colder. Each layer of ice tells a story in a language made of chemistry and physics, and the scientist who learned to read that language can trace the long, slow breathing of our planet, its rhythms, its fevers, its long, cold sleeps. If your eyes feel heavy right now, that's okay, let them close. The story will still be here. Think about what it means to hold a cylinder of ice drilled from 2 miles below the surface of Antarctica, knowing that the air inside it last moved freely through an open sky more than 500,000 years ago. What does it mean to hold something that old? What does it say about time and how we experience it? We tend to think of time as something that flows past us. We stand still and it moves. But when you hold ancient ice, when you look at the compressed layers of centuries stacked one on top of another in a cylinder the length of your arm, time starts to feel less like a river and more like a landscape. Something you could, if you had the right tools, walk through, explore, map. The ice cores from Antarctica are one of the most important scientific records our species has ever found. They are more detailed in some ways than any written history, because written history is what people chose to remember. The ice remembers everything. Every volcanic eruption, every shift in carbon dioxide, every slight wobble of the Earth's orbit that changed the angle of sunlight over thousands of years. The ice kept all of it, quietly, in the dark, in the cold, in layers so thin you have to count them like the rings of a very ancient tree. Let's move a little deeper now, both into the story and into this quiet night. There is a place in Antarctica called the Transantarctic Mountains, and I want you to picture them, even though they look like nothing you have ever seen in photographs or travel magazines. These are not cozy mountains. They are not the kind of mountains with chalets at the base and hiking trails that wind up through meadows and pine forests. They are mountains that rise sharp and dark and almost completely free of vegetation from a flat white sea of ice. Some of them are over 4,000 meters tall. Their peaks are bare rock, black and grey and rust-coloured, dusted with snow that doesn't stick for long because the wind takes it away. They look ancient in a way that even ancient things rarely look, like they have been standing here since before the word mountain existed. The Transantarctic Mountains divide the continent roughly in two. On one side is East Antarctica, which is the older, thicker, more stable part of the continent, a massive dome of ice sitting on a rocky platform that has barely moved in hundreds of millions of years. On the other side is West Antarctica, which is younger, thinner, more complicated, and in some places sits on ground that is actually below sea level, held up only by the weight and pressure of the ice above it. Between and beneath these mountains, scientists have discovered something in the last few decades that quietly changes everything we thought we knew about this frozen place. They discovered lakes, liquid lakes, full of water, existing in the deepest darkness beneath kilometers of ice, warmed just barely by the heat coming up from the Earth itself. Not warm enough to be comfortable, not warm enough for most things we know, but warm enough to be liquid, warm enough possibly for life. The first of these lakes to be discovered, or at least to be confirmed, is called Lake Vostok, and it is not a small lake. It is one of the largest lakes on Earth. It stretches for about 250 kilometers in one direction and 50 in another. It is about 900 meters deep at its deepest point. It has been sealed beneath the ice for somewhere between 15 and 25 million years, and it has been completely isolated from the rest of the world for all of that time. 25 million years. For a moment, just breathe. 25 million years ago, the continents we know were already roughly in the positions they are now, but the world looked very different. The Himalayas were still rising. The Mediterranean Sea didn't quite exist yet. There were forests in Antarctica. Real forests with trees and ferns and insects and small mammals that lived in a warm, wet, lush landscape that looked nothing like the white wilderness we know today. And then, slowly, over millions of years, the climate shifted. The ice came, the forests died, the animals left or died with them, and the lakes that had been fed by rain and rivers in the warm green land became sealed beneath a growing cap of ice, cut off from the sky forever. And they are still there. We found Lake Vostok in the 1990s, using radar equipment mounted on aircraft that could send signals through kilometers of ice and read what was underneath. The signals showed a flat, still surface where ice should have been jagged, and scientists understood what that meant. Water, liquid water, a vast, still, ancient lake hidden beneath the white. Russian scientists at the Vostok Research Station, which sits directly above the lake on the surface, have been drilling toward it for decades. The drilling is incredibly careful and slow, because everyone understands what is at stake. If the drill punches through into the lake without proper precautions, you might contaminate it, bringing modern bacteria and chemicals from the surface into a world that has been sterile and sealed for millions of years. You might destroy the very thing you're trying to study. So the drilling proceeds with enormous patience, millimeter by careful millimeter, year by year. In 2012, after more than 20 years of careful work, the drill finally broke through into the lake. The pressurized water from below shot up into the borehole and then froze, sealing itself off again, as if the lake was protecting itself. Scientists collected that frozen water and have been studying it ever since. What they found is still being debated and studied, but some researchers believe they detected the genetic signatures of microorganisms, simple living things, Bacteria-like creatures adapted to the dark and the cold and the pressure and the complete absence of sunlight. Other scientists are more cautious and say the results need more confirmation. The debate continues quietly in laboratories far from the ice. But the question is already extraordinary. What if something is alive down there? Not alive in the way we usually think about life. Not warm-blooded and breathing and looking back at you with curious eyes, but alive in the deep, patient, chemical way that life sometimes is, in the oldest and most fundamental sense of the word. What if life has been going on in that frozen darkness, completely alone, for 25 million years? What would it have become? Let's not rush to answer that. Let the question just rest with you for a while, soft and open, the way the best questions do. We'll come back to it. We have all night. As we move through this story, I want to make sure you stay comfortable. If you've shifted position recently, take a moment now. Find a good place for your head. Let your hands relax wherever they are. Notice if you're holding any tension in your shoulders or your face, and just let it go. There is nowhere you need to be right now. There is nothing you need to do. Just let the words come in and let the warmth hold you. The world outside is doing whatever it does, but in here, for now, we're somewhere else. We're at the bottom of the world, in the dark beneath the ice, where time moves in a different way. There is another thing about Antarctica that I want to share with you before we close this first part of our journey, something that is not about lakes or ice cores or hidden mountains, but about the sky. Antarctica is one of the best places on Earth to see the aurora australis, the southern lights, the counterpart to the northern lights you may have seen photographs of, those green and pink and violet curtains of light that hang and ripple in the high atmosphere like something dreamed by an artist who had never seen anything ordinary. The auroras happen because of the sun. Not the sun's light exactly, but its wind. The sun is constantly sending out a stream of charged particles, tiny pieces of itself, flying outward in all directions at incredible speed. When these particles reach the Earth, they are mostly deflected by our planet's magnetic field. But at the poles, the magnetic field dips down toward the Earth, and the particles follow it down into the atmosphere. And when they collide with the gas molecules up there, those molecules release light, curtains and waves and spirals of light, silent and slow and unutterably beautiful. Imagine lying on your back on the Antarctic ice on a clear winter night. It is 60 degrees below zero. You're bundled in so many layers that your body is a small warm centre, inside an enormous cocoon of fabric and insulation. You can see your breath, but only barely, because the air is so dry there is almost no vapour in it. The stars above you are extraordinary, more stars than you have ever seen in your life, because there is no light pollution for thousands of kilometres in any direction. The Milky Way is a river of white running from one horizon to the other, and then, slowly, at the edge of that star-filled sky, a faint green shimmer begins. It grows, it bends, it ripples like a curtain moved by a soft wind, then purple at the edges, then white, then a deep, aching blue. The whole sky, from horizon to horizon, is moving. It doesn't make a sound. That is one of the things people always expect, some kind of music, some kind of hum, but there is nothing. Just the wind and the light and the stars and the cold that you are somehow for this moment not feeling. People who have seen the aurora, either the northern or southern variety, often describe a feeling of being very small in a way that is not frightening but deeply peaceful, as if for a moment the universe looked down at you and said, quietly, without any urgency at all, here you are. Here is everything. Here is how large it all is. And somehow that largeness does not crush you. It holds you. That is Antarctica, at its most beautiful and most mysterious. A place where the usual rules of human experience are suspended, where time feels different, where light behaves differently, where silence is so complete that your own heartbeat seems loud, where the earth itself is doing something under your feet that you cannot see or measure or fully understand. This is why Antarctica is sometimes called the last wilderness, and it is a true name. There are no permanent human residents here. There are research stations run by 30 or so different countries where scientists live and work in shifting rotations. But no one was born here. No one has their family home here. No one has built a city or planted a garden or buried their ancestors in this ground. In a world where almost every place has been touched and changed and claimed by human hands, Antarctica remains, somehow, itself, which makes the question of what lies beneath it all the more astonishing. We are only beginning, in the long history of science, to understand this place. The radar surveys, the drilling projects, the satellite measurements and ice core studies, all of this work is recent. Most of it has happened in the last 50 years, and what it has already shown us is stranger and more complex and more beautiful than almost anyone expected. There are more than 400 subglacial lakes discovered so far. Not just Vostok, but hundreds of others, scattered beneath the ice like a hidden geography, connected by rivers that flow, impossibly, under kilometres of frozen weight. There are volcanoes under the ice, slowly warming the ground above them. There are entire mountain ranges, the Gambutsov Mountains, completely buried under the East Antarctic ice sheet, never seen by human eyes, mapped only by the faint echoes of radar waves. There is a whole world down there, patient, dark, cold, and waiting. And tonight, as you lie in your warm bed and the quiet of the night settles over you, we are only at the very beginning of learning what that world is. So let your eyes close, if they haven't already. Let your body be heavy and still. The ice has been there for millions of years. It is in no hurry to give up all its secrets. And neither are we. In the next part of our journey, we'll go deeper. We'll follow the rivers that run under the ice, visit the hidden mountains, and start to ask the oldest and most wonderful question of all. What does it mean that life might exist in a place where, by every rule we thought we understood, it simply should not be able to? But that can wait. For now, the wind is blowing softly across the white plain. The stars are very bright and very far away, and the ice is doing what it has always done, holding everything gently in the dark, keeping it all safe and still and quiet. Just like the night holds you. Let's go back to Antarctica. We were standing on the surface of that vast white plain. We had talked about the ice, about how ancient it is, about the air bubbles trapped inside it that hold the breath of a world that existed long before us. We had just discovered together that beneath the ice there are lakes, hundreds of them. Liquid lakes in the deepest darkness, sealed away from the sky for millions of years. Tonight, in this second part of our journey, we are going to go further. We are going to follow the water. We are going to descend slowly and gently into the hidden geography that lies beneath the ice sheet, and we're going to look at what scientists have been piecing together year by patient year about the world that exists down there. And somewhere along the way, we will ask a question that has no clean answer yet. A question that scientists are still working on, still debating, still lying awake at night thinking about in their research stations and university labs. Is something alive down there? But first, let's go deeper into the ice itself. Let's understand what we're walking on before we walk through it. For a moment, just breathe. Let your chest rise and fall slowly. Let your hands rest wherever they are, heavy and warm. The world outside your window is doing its nighttime things, settling, cooling, going quiet. And in here, we're going somewhere old and still and wonderful. Imagine you're in a slow elevator. Not a modern glass elevator in a tall city building, but something older and simpler. A cable and a box descending steadily into the earth. The walls around you are ice, but not the ice you know from ordinary life. This ice is blue. A deep, extraordinary blue that you almost don't believe is real the first time you see it. The blue comes from the compression. When snow falls and sits and is compressed by more snow falling on top of it, year after year, century after century, the air bubbles inside it are slowly squeezed out. And when almost all the air is gone, the ice absorbs the red and yellow parts of light and reflects back only the blue. It is the same reason the deep ocean looks blue. The same physics, the same absence of red light, but in frozen form, preserved and still and ancient. As you descend, the temperature drops. At the surface of Antarctica, the temperature can fall to minus 80 degrees Celsius in the winter. That is so cold that if you poured a cup of boiling water into the air, it would freeze before it hit the ground. But as you go deeper into the ice, something strange happens. The temperature actually begins to rise very slightly, because the ice insulates. The cold cannot reach all the way down, and from below, the Earth itself is breathing out warmth, the slow geological heat of a planet that has been cooling since its formation over 4 billion years ago. By the time you reach the bottom of the ice sheet, in certain places, the temperature at the interface between ice and rock is just barely at the melting point. Not warm enough for you to feel comfortable, not warm enough for most forms of life as we know them. but just barely, precisely, exactly warm enough for water to remain liquid rather than freeze. And that is where the lakes are. We talked about Lake Vostok in our first part. But I want to spend a little more time there, because Vostok is not just a lake. It is a kind of symbol. It is the place where everything we thought we knew about where life can exist was quietly, gently shaken. Lake Vostok sits beneath the Vostok Research Station, a Russian outpost in East Antarctica that has been operating since the 1950s. The station was built during the Cold War, when the Soviet Union and the United States and several other countries were racing to establish a presence on the continent, not for military reasons, since Antarctica is one of the few places on Earth protected by international treaty from any military use, but for scientific and strategic prestige. Being in Antarctica meant something. It meant your country could operate in the hardest place on Earth. The scientists at Vostok in those early years were doing work that had nothing to do with subglacial lakes. They were measuring temperature, studying the upper atmosphere, watching the behaviour of the geomagnetic field. The lake beneath them was not discovered by anyone standing there on the ice. It was found from the air and from space, by people who had never visited the station at all. The story of discovering Lake Vostok is a slow and collaborative one, which is fitting for a continent that seems to teach patience to everyone who visits it. In the 1970s, a British scientist named Gordon Robin was using radio echo sounding, a technique that involves sending radio waves through the ice and measuring how they bounce back to map the thickness of the ice sheet. When radio waves pass through ice and hit solid rock, they bounce back in a certain way. But when they hit a flat, still surface of liquid water, they bounce back differently. The reflection is smoother, stronger, more mirror-like. Robin noticed something strange in the Vostok region, a reflection that didn't look like rock. He suggested there might be liquid water down there, but the idea was not taken seriously for another decade or more. Then, in the 1990s, better satellite imagery revealed the flat, still surface beneath the ice sheet more clearly, and the scientific community began to accept what the data had been suggesting all along. There was a lake down there, a very large lake, one of the largest bodies of fresh water on Earth, hidden beneath 4 kilometers of ice. The dimensions, when they were finally mapped carefully, were astonishing. 250 kilometers long, 50 kilometers wide, nearly a kilometer deep, holding roughly 5,000 cubic kilometers of water. For comparison, that is more water than Lake Ontario in North America, and it had been there, isolated and sealed, for somewhere between 15 and 25 million years. Different scientific studies give different estimates. The uncertainty is itself meaningful. We are talking about a span of time so long that it swallows human imagination whole. Let's drift a little further. 50 million years ago, our ancestors were not human yet. The creatures that would eventually become us were small, forest-dwelling primates living in Africa, unrecognizable as the ancestors of anything we know today. The continents were in slightly different positions. The Himalayan mountain range was still growing taller. The Arctic was warmer and had far less ice than it does now. And in Antarctica, the ice sheet was already advancing, already sealing away the lakes and rivers and warm valleys that had once made this a green and living place. 25 million years ago, the picture is even more different. The world was warmer overall. What are now the plains of the American Midwest were tropical seafloors. India had not yet fully collided with Asia. The Mediterranean Sea, as we know it, did not exist. And Antarctica, while cooling, still had pockets of vegetation around its edges, forests of beech and conifer clinging to the coastline in the fading warmth. In both of those distant eras, the lakes that would become Lake Vostok were open to the sky. Rain fell into them, rivers fed them, sunlight touched their surfaces, and whatever lived in them, whatever microorganisms and small aquatic creatures made their home in those ancient waters, they were connected to the larger world. And then the ice came, slowly, over thousands of years, not all at once, not like a disaster, but like a very long and very cold season that never ended. The ice grew, it covered the rivers, it covered the forests, it covered the lakes, and the creatures that had lived in those open waters, if any of them survived the transition, found themselves sealed in a world that was shrinking and darkening and cooling from above, even as the Earth's warmth from below kept the very bottom of their world just barely liquid. What happened to them in the millions of years that followed? That is the question. If your eyes are growing heavy, let them close. You can let these words become a kind of background hum, like distant water, like a voice in a warm room while you drift. There is no test. There is no moment where you need to be alert. Just let the story wash over you. The scientists who study extremophils, which is the name given to organisms that live in extreme conditions, have shown us in the last few decades that life is far more stubborn and inventive than anyone imagined. Before the age of modern biology, most scientists assumed that life needed warmth and sunlight and relatively stable conditions to exist. The discovery of ecosystems living around hydrothermal vents on the deep ocean floor in the late 1970s changed that understanding forever. Those vents, cracks in the ocean floor where superheated water rich in minerals shoots up from the Earth's interior, are surrounded by life, not sparse, struggling life. Rich, complex, thriving ecosystems. Tube worms as long as your arm, blind shrimp, giant clams, bacteria that form thick orange and white mats on the rock surfaces, all of it living in total darkness at crushing pressure, in water that would kill most surface organisms instantly. None of it uses sunlight. It uses chemosynthesis instead, a process by which bacteria extract energy from the chemicals in the vent water, particularly sulfur compounds, and use that energy to build organic molecules the same way surface plants use sunlight to build them. The shrimp eat the bacteria. The tube worms host bacteria inside their own bodies. The whole food web runs on chemistry, not light. This discovery, made from a small submarine diving to the floor of the Pacific Ocean near the Galapagos Islands in 1977, changed our understanding of life so fundamentally that it is still being absorbed. Before that dive, most biologists would have said that all life on Earth ultimately depends on sunlight. After it, that sentence can no longer be said with confidence. And this discovery is directly relevant to what might be living in Lake Vostok. Because Vostok, like the deep ocean vents, is a world where sunlight has not reached in millions of years. If life is present there, it cannot be living on photosynthesis. It must be living on something else. The chemistry of the water, the minerals dissolved from the rock over millions of years, the heat from the earth beneath. When the first samples of water from Lake Vostok were analysed, after the breakthrough in 2012, the results were preliminary and disputed. Some researchers reported finding DNA sequences in the refrozen water that didn't match any known organism, which could mean contamination from the drilling process, or could mean something extraordinary. Other researchers found sequences that seemed to match known types of bacteria. The debate continues, but even the possibility is enough to make the mind grow still and wide with wonder. Think about it. An organism that has been evolving in complete isolation, in the dark, under pressure, in near-freezing water, for 25 million years. Whatever it started as, it would not be the same thing now. Evolution does not stop just because the environment is extreme. It keeps going slowly, generation by generation, mutation by mutation. Over 25 million years, even slow evolution adds up to something very different from what it began as. We cannot know what that something is. Not yet. Possibly not for many years, given how carefully and slowly the scientific work must proceed. But the question hangs in the cold air of Antarctica like a breath that hasn't yet dissipated, visible and real and waiting. Let's drift a little further now, away from Vostok, and explore some of the other hidden things beneath the ice. Imagine you are in a small plain, very high above Antarctica. Below you is nothing but white, for as far as you can see in every direction. The continent is so large that if you flew straight across it, you would be in the air for several hours. From up here it looks simple, it looks like a blank page, but the plane you're in is special. It is fitted with instruments that can see through the ice. Ground-penetrating radar, gravity sensors, instruments that measure tiny variations in the magnetic field. And what these instruments show you, as you fly across that blank white page, is something completely different from what your eyes see. Beneath the ice, there are mountains. Not small hills, not gentle rises. Mountains, enormous ones. Jagged and dramatic, with peaks and valleys and steep cliffs. A whole dramatic landscape hidden under kilometers of frozen silence. In some places, the mountains are tall enough that their very tips poke through the surface of the ice, creating the dark, rocky outcrops that Antarctic explorers called nunataks, an Inuit word for the peaks of mountains surrounded by glacial ice. But most of the mountains are completely buried. You would never know they were there from the surface. The most mysterious of these hidden mountain ranges is called the Gamburtsev Mountains. They were first detected in the 1950s by Soviet scientists using seismic measurements, and the data has been refined many times since. The Gamburtsevs are located near the centre of East Antarctica, far from any coast, buried under the thickest and oldest part of the ice sheet. They are remarkable for several reasons. First, their size. The peaks of the Gamburtsev Mountains reach up to about 2,700 metres in height. That is comparable to many well-known mountain ranges in Europe and North America. They are not small. They are proper, substantial mountains. Second, their shape. Mountain ranges are usually the result of one of two processes. They are either the folded and pushed up edges of colliding tectonic plates, like the Himalayas, which are being squeezed up by the collision of India with Asia, or they are volcanic ranges, built up by the accumulation of lava over millions of years. The Gamburtsevs don't fit neatly into either category. Their shape is sharp and jagged, more like young mountains than old ones, but their underlying rock is ancient, billions of years old. So we have a paradox. Very old rock, shaped like young mountains. How? The current best hypothesis is that the Gamburtsevs are the remnants of an ancient mountain range that was uplifted billions of years ago, worn down nearly flat over hundreds of millions of years, and then uplifted again more recently by geological processes we don't yet fully understand. And then, before erosion could wear them down a second time, the ice came and covered them, preserving them in their current form like an insect preserved in amber. So the Gamburtsev Mountains are, in a sense, fossils. Not fossils of living creatures, but fossils of a landscape. A preserved relic of a geography that would have been worn away long ago if the ice had not arrived to protect it. There is something deeply moving about that idea. The ice, which we tend to think of as a destroyer, as the thing that covered the green Antarctica and erased its life, also turned out to be a preserver. It kept these mountains exactly as they were on the day it covered them millions of years ago, unchanged and waiting. For a moment, just breathe. The world is full of these inversions, these moments where something that seems like an ending turns out to be a form of keeping. The ice that buried the forests also kept the fossil pollen of those forests perfectly preserved, so that today we can know exactly what trees grew there and when. The darkness that sealed away Lake Vostok also insulated it from the extinctions and climate changes that swept through the surface world. The cold that makes Antarctica the hardest place on Earth to live also makes it the best place on Earth to preserve records of the past. There is a philosophy in that. If you let it settle in slowly enough, the things that cover us sometimes keep us. The stillness that feels like loss can be a form of patience. The cold can be a kind of grace. But let's not stay too abstract for too long. Let's go back to the physical world, because there are more things under the ice that deserve our quiet attention. We mentioned earlier that there are over 400 subglacial lakes beneath Antarctica. Vostok is the largest, but many of the others are fascinating in their own right. And what scientists have discovered in the last decade or so is that these lakes are not isolated from each other. They are connected. Beneath the ice, there are rivers, subglacial rivers, flowing through the darkness from one lake to another, carrying water and minerals and possibly whatever microscopic life might have evolved in each lake's isolated waters. This was a surprising discovery. When scientists first realized there were lakes under the ice, they imagined them as separate, isolated systems, each one a little pocket of ancient water sealed off from everything else. But the data from multiple surveys started to tell a different story. The lakes fill and drain. Over years and decades, one lake will slowly accumulate water and then release it, and the water flows through channels in the ice to another lake somewhere else. In 2010 and the years that followed, scientists watched in near real time as lakes drained and refilled, tracking the changes in the ice surface above them using satellites that can detect rises and falls of just a few centimeters. A lake draining under 4 kilometers of ice changes the shape of the surface just slightly. The surface above it sinks, very slowly, as the water below moves away. Then, when the receiving lake fills up, the surface above it rises. These tiny changes, tracked by satellites over months and years, revealed a hidden plumbing system of extraordinary complexity. Water was moving under the ice, continuously, along paths that had probably been flowing for millions of years, from high points to low points, following the shape of the rock beneath, the same way any river follows the landscape of the ground it flows over, except that this landscape is made of deep rock and ancient stone, and has never felt the warmth of sunlight. And if water flows between the lakes, then potentially life flows between them too. Microorganisms that evolved in one isolated lake might, over millions of years, have been carried by these subglacial rivers to other lakes. Or two lakes that were once separate might have exchanged organisms when their drainage channels connected. creating a new mixture of life that is different from either source. The subglacial water system of Antarctica is beginning to look less like a collection of isolated ponds and more like a vast interconnected world of its own. Dark and cold and ancient, but connected, moving, living perhaps in ways we're only starting to be able to imagine. This is one of the most exciting frontiers in modern biology and earth science. Not because it has been conquered, but because it has barely been approached. We are, in scientific terms, standing at the very edge of this continent's secrets, looking in with limited tools and enormous curiosity. Now, let me take a moment to invite you back into your own body, wherever you are right now. Maybe you're lying very still and the weight of the blanket is something you can feel perfectly. Maybe your breathing has slowed down considerably from where it was when you first pressed play. Maybe you're right at the edge of sleep, that soft boundary where the words start to feel like they're coming from somewhere very far away and very calm. If you are there, just let yourself go. You don't need to hold on. The story will still be here. The ice will still be there. The hidden lakes will still be full and dark and waiting. Nothing is going anywhere tonight. And if you are still awake, that is also fine. Let your eyes stay closed if they are closed. Let your body be heavy. You are doing exactly what you are supposed to do. As we drift through this second part of our journey, I want to take a moment to think about the people who actually go to Antarctica. Because it is one thing to talk about the science from a comfortable distance, from a warm room with a voice coming through headphones. It is another thing entirely to be there. The people who work at Antarctic research stations, and there are roughly 4,000 of them during the summer months, and about 1,000 who stay through the winter, are a particular kind of person. Not necessarily the most dramatic, daring adventurer type of person. Often they are quiet, methodical scientists or engineers or support staff who keep the stations running, but they share something, a willingness to be far from everything familiar, a comfort with silence and cold and the long dark winter. The Antarctic winter is something worth describing slowly, because it is unlike anything most of us will ever experience. The sun sets in late April, and it does not rise again until late August. 4 months of continuous darkness. Not the dark of a cloudy night, where you can still see the dim shapes of things. A deep, unrelenting darkness, broken only by the moon when it is above the horizon, and by the stars, and by the aurora australis when it chooses to appear. During those winter months, the temperature at the South Pole Station, which is the American research facility built at 90 degrees south, falls to somewhere between -50 and -80 degrees Celsius on a regular basis. The record low temperature ever recorded on Earth was measured here, at the Russian Vostok Station in 1983. It was -89.2 degrees Celsius. That is colder than the surface of Mars on an average day. In those conditions, going outside is not a casual decision. It requires full protective clothing, carefully checked and double-checked, a face mask to prevent the air from freezing your lungs, goggles to protect your eyes, and you do not go outside alone, ever, because if something goes wrong, if your equipment fails or you fall and injure yourself, the cold will take you in minutes. And yet the people who spend winters in Antarctica often describe them as among the most profound experiences of their lives. The silence is extraordinary. The stars are extraordinary. The sense of being at the very edge of the human world, beyond the reach of the internet and phone calls and the constant noise of modern life, is something that changes people. Some of them talk about a kind of deep rest that comes over them during the long dark months, as if the body, deprived of sunlight and the usual rhythms of a busy world, finally stops and drops into something very slow and very quiet. Something that feels less like depression, though that happens to some people too, and more like the sleep of winter, like the Earth itself in high latitudes pulling inward and resting. There is a word in several northern languages for this kind of winter rest. The Norwegians call it the mørketid, the dark time. It is not entirely comfortable, but it is also not entirely bad. It is a season of inwardness, of slow thought and deep reading and long, quiet meals and conversations that take their time. In Antarctica, the mørketid is more extreme than anywhere else on Earth, and the people who live through it and come out the other side into the returning light of spring often say that they understand something afterwards that they didn't understand before. Something about time and stillness and what it means to wait. I think about that sometimes when I think about Antarctica. The whole continent is doing a version of that waiting. The ice is waiting. The hidden lakes are waiting. The buried mountains are waiting. Whatever might be alive in the darkness beneath the ice is waiting, in the slowest and most patient way imaginable, without knowing what it is waiting for. Let's drift a little further. There is one more thing I want to explore in this part of our journey, and it has to do with something that Antarctica was before it became Antarctica. Before the ice, before the cold, before the long silence. What was this place? The answer is one of the most quietly astonishing facts in the entire story of our planet. Antarctica was not always at the bottom of the world, and it was not always cold. 250 million years ago, all the continents we know were joined together in one enormous supercontinent that scientists call Pangaea. Africa and South America were pressed together. Europe and North America were one. India was wedged against Africa, and Antarctica was connected to Australia and South America, nestled in the centre of this giant landmass, nowhere near a pole. The climate of Pangaea was complex and varied. Parts of it were hot and dry. Parts were tropical and wet. And the region that would eventually become Antarctica was somewhere in the temperate zone, with seasons and forests and rivers and animal life, not dramatically different from the mid-latitudes of today, livable, green, ordinary in the best possible way. Over millions and millions of years, Pangaea broke apart. The continents moved, driven by the slow convection of the semi-molten rock deep in the Earth's mantle. South America pulled away from Africa. India broke free and began its long, northward drift toward Asia. Australia separated from Antarctica, and Antarctica slowly was left behind. It drifted toward the South Pole, pulled gradually over tens of millions of years into the position it now occupies. As it moved south, the climate changed. The warm currents that had once connected it to the warmer ocean to the north were cut off as the continent separated from its neighbours. A powerful circular current formed around it, the Antarctic Circumpolar Current, the largest ocean current on Earth, flowing endlessly around the continent in an unbroken ring and effectively insulating it from the warmer waters of the north. Without warm water reaching its shores and positioned now directly over the South Pole, Antarctica began to cool. The forests died. The animals moved to more hospitable regions or died with the forests. The rivers froze, the lakes froze, and slowly, over millions of years, the ice sheet grew, starting as a cap on the highest mountains, then spreading outward and downward, covering valleys and plains, burying the evidence of everything that had been there before. By about 34 million years ago, a significant ice sheet covered East Antarctica. By about 23 million years ago, the ice had become largely permanent, and by about 14 million years ago, something close to the ice sheet we know today was in place, relentlessly cold, relentlessly white, covering the continent from coast to coast and from mountain top to buried valley floor. But under all of that ice, the old world was still there, the rock that was once the floor of a temperate forest, the ancient river channels now filled with ice, the dried and compressed remains of leaves and wood and pollen from trees that grew millions of years before the first human being drew breath. All of it, preserved in the frozen darkness, waiting. In the 1960s and 70s, paleontologists began finding fossils in the few exposed rock areas of Antarctica, the places where the ice has not covered everything. What they found there confirmed the ancient warmth of this place. Fern fossils, tree stumps, fossils of dinosaurs, actual dinosaurs, that once walked across what is now the coldest place on Earth, fossils of early mammals, fossils of fish from warm freshwater rivers, and in 1991 a remarkable discovery was made on a rocky outcrop in the Transantarctic Mountains. Scientists found a partial skeleton of a small cat-sized marsupial, an ancient relative of modern kangaroos and wombats, living proof that 50 million years ago, warm-blooded, fur-covered animals were living and breathing and raising their young on the continent we now associate with nothing but cold and ice. Its name is Antarctidolops, and I find it almost unbearably poignant. This small creature, living in a warm forest that does not exist anymore, on a continent that would become the most inhospitable place on Earth, having no idea, of course, because animals don't have ideas about such things, that the world it lived in was temporary, that the ice was coming, that millions of years later human beings would find the compressed remnants of its bones and understand from them that this frozen place had once been alive in a completely different way. Everything changes. That is one of the things Antarctica teaches. If you sit with its story long enough, everything changes, and slowly and without drama, and on a timescale that makes our entire history feel like a single breath, which is somehow both humbling and comforting. For a moment, just breathe. The world is old, so much older than we usually remember. And in its great age, it has been many different things: warm and cold, green and white, loud with life and silent as stone. It has changed before, and it will change again. And all of this change is happening so slowly that in the span of one human life, it is almost impossible to perceive. We are here for such a short time, and yet we are made of the same atoms as that ancient marsupial, as those buried forests, as the ancient air locked in the ice. We are part of the same long story, just a very recent chapter of it. The ice holds all those earlier chapters in its long cold memory. And tonight, we have barely begun to read them. Let your breathing slow down a little more if you can. Let the weight of the night settle around you. You have nowhere to be, you have nothing to do. You're just here, in the warm dark, while outside somewhere, the wind is blowing across a landscape impossibly far away, scattering snow that has been falling for a very long time. We had followed the ice down through its ancient blue layers, found the hidden lakes beneath it, traced the buried rivers that connect them in the dark, and stood for a moment beside the fossil bones of a small warm creature that once lived in forests, where now there is only frozen silence. We had let the great age of Antarctica settle over us like something slow and immense and patient. Now we go deeper. Not deeper into the ice exactly, though we will do that too. Deeper into the mystery. Deeper into the questions that the scientists who study this continent carry with them. Questions they think about on long flights home, in the middle of the night in their research stations, in the quiet moments between data points and measurements and carefully written papers. The question at the centre of everything, the one that connects all the other questions, is this. What does Antarctica tell us about what is possible? Not just what is possible on this planet, what is possible anywhere. Because Antarctica, as strange as it sounds, is one of the most important places we have ever found for thinking about life in the universe. Not because it is dramatic, not because it is violent or explosive or obviously significant, but because it is extreme, and the extreme places on Earth teach us where the edges of life are, and once we know where the edges are, we know what to look for somewhere else. But let's not rush to space yet. There is still so much here on this frozen continent that deserves our slow attention. Imagine you're standing inside a tunnel carved into the ice. Not a tunnel made by machines, though some exist, but a natural one, the kind that forms when a glacier moves over an uneven rocky surface and creates a space between the ice above and the stone below. The tunnel is narrow and low. You would have to crouch to move through it. The walls are that deep, impossible blue. Your headlamp throws the light ahead of you and it bounces back off the ice in a way that makes everything feel submerged, as if you are not in ice at all, but in very still water. The silence in this tunnel is unlike any silence above. On the surface of Antarctica there is always wind, and wind has a voice. But here, underground, the ice absorbs sound the way thick walls absorb it. Your own footsteps are muffled. Your breathing sounds close and private. Even the slow creak and groan of the glacier moving above you, which happens sometimes, arrives as a distant low vibration rather than a sound. More something you feel in your chest than hear with your ears. This is the interior world of Antarctica. Not the dramatic open white of the surface, but something smaller and more intimate. A cathedral made of compressed time, its walls holding millions of years of memory in every centimetre of their thickness. The ice has been moving here, the way all glaciers move, though very slowly. The ice sheet of Antarctica is not static. It flows under the tremendous pressure of its own weight, outward from the highest and thickest parts of the continent toward the coast. In some places, this flow is almost imperceptibly slow, a few centimetres per year. In others, particularly in the fast-moving ice streams that drain the West Antarctic ice sheet, the ice moves several metres per day, quick enough, in geological terms, to feel almost urgent. These ice streams are some of the most important features of the Antarctic ice sheet, and also some of the most closely watched by scientists who study climate change. They are the main pathways by which ice moves from the interior of the continent to the ocean, and if they speed up, if something disrupts their movement and makes them flow faster, the consequences could be significant in ways we will explore a little later. But first, let's stay in our tunnel a moment longer. Let's talk about what the ice itself knows. Earlier we mentioned ice cores, those long cylinders of ancient ice drilled out of the sheet and studied in laboratories around the world. The oldest continuous ice core ever recovered was drilled at a site called Epica Dome C also known as Concordia Station, in East Antarctica. It goes down 3,270 metres and reaches back through 800,000 years of climate history. 800,000 years. That is the record. 800,000 years of atmosphere, preserved in annual layers of compressed snow, each layer containing information about the temperature, the greenhouse gas concentrations, the volcanic activity, and the cosmic ray flux of that particular year. But scientists believe there is older ice still, deeper down, in certain parts of Antarctica, where the ice sheet has been stable the longest, and where the heat from the Earth below has not melted the oldest layers. In 2023, a project called Beyond Epica was working to find and drill a site that might yield ice, going back 1.5 million years or more. The target site is in a region called Little Dome Sea, near the existing Concordia Station. Why does 1.5 million years matter? Because approximately a million years ago, something changed in the rhythm of the Earth's ice ages. Before that time, ice ages and warm periods cycled roughly every 40,000 years, driven by a particular wobble in the Earth's orbit around the Sun. But around 900,000 years ago, the cycle changed. Ice ages began lasting longer, roughly 100,000 years each, with shorter warm periods in between. Scientists call this the mid-Pleistocene transition, and they don't fully understand why it happened. The leading hypothesis involves carbon dioxide. The idea is that gradually, over geological time, the amount of carbon dioxide in the atmosphere decreased, making the world slightly more susceptible to cooling and tipping the ice age rhythm from one cycle to another. But to test this hypothesis, you need ice core records from before the transition. You need to see what the atmosphere was actually doing more than a million years ago. And the only place on Earth where that information might still be preserved, locked in ancient ice, is in Antarctica. So the drilling continues. Patient, careful, millimetre by millimetre. The deepest drill sites are among the most technically demanding scientific projects on Earth. The ice at those depths is under extraordinary pressure. The temperature is extreme. The logistics of keeping a drilling operation running smoothly in the middle of one of the most remote and hostile environments on Earth require years of preparation and the cooperation of dozens of scientists and engineers from multiple countries. And yet it gets done. Year after year, the drills go deeper, the ice cores come up. The tiny trapped bubbles of ancient air are released, after hundreds of thousands of years in the dark, into the clean light of a laboratory, and their chemistry is measured and recorded and compared. There is something that moves me about this process. These scientists are not doing dramatic work, at least not in the way that word is usually used. There are no explosions. There is no discovery that anyone not already following the field would notice immediately. The work is slow and quiet and iterative, built up from data point after data point after data point, over years and decades. But what they are doing is extraordinary. They are reading the planet's autobiography. They are finding the chapters that no human witness ever recorded, because there were no human witnesses. They are reconstructing, from chemistry and physics alone, what the sky was like on a random Tuesday afternoon 800,000 years ago, what the temperature was, what the winds were doing, what gases were floating in the air. The Earth kept a diary, and the ice is where it is stored. Let's drift a little further. Now I want to take you somewhere that is not underground and not inside a tunnel. I want to take you to the coast of Antarctica, where the ice meets the ocean, because this boundary, this edge where the frozen continent encounters the living sea, is one of the most dynamic and important places on Earth. The coastline of Antarctica is not a smooth, gradual thing. It is dramatic. In many places, the ice sheet extends beyond the rocky edge of the continent and out over the ocean, forming what are called ice shelves. These are vast, flat platforms of floating ice, still attached to the continent but resting on the surface of the sea. The Ross Ice Shelf, the largest, is roughly the size of France. The Ron Ice Shelf is nearly as large. Together, the ice shelves of Antarctica represent some of the most extraordinary geographic features on the planet. Great white plains extending over the ocean, flat as a table, with edges that drop vertically into the sea in cliffs sometimes hundreds of meters tall. These cliffs are blue-white at the top and deepening to a dark, vivid blue at the waterline. And below the waterline they continue downward, the underside of the shelf hanging in the cold water, creating an enormous overhanging ceiling of ice below the surface. In the water beneath the ice shells, in the permanent darkness under hundreds of meters of floating ice, there are ecosystems. Communities of creatures adapted to the cold and the dark. Fish with antifreeze proteins in their blood, sea spiders larger than dinner plates, strange, translucent invertebrates that have never been seen by anyone except the scientists who carefully lowered cameras through the ice to look. One of the most remarkable of these discoveries happened in 2021, when scientists drilling through the Filchner ice shelf in West Antarctica lowered a camera through the borehole and found, on a rock at the bottom, something they were not expecting at all. Sponges. Not just one or two sponges, but a community of them, attached to a boulder on the seafloor beneath 900 meters of ice, in complete darkness, nearly 260 kilometers from the open ocean and any possible source of sunlight. Sponges are filter feeders. They eat by drawing water through their bodies and capturing tiny particles of organic matter from it. The question of what these sponges are eating and how organic matter gets to them in such an isolated location is a genuine scientific puzzle that has not been fully solved. One possibility is that deep ocean currents occasionally carry food particles from the open ocean all the way under the ice shelf to where the sponges live. Another is that local currents swirl organic matter up from the sediment on the seafloor. A third, more speculative possibility is that there are chemical or geological processes happening near those boulders that support microbial life, and that the sponges are somehow feeding on that. Whatever the explanation, the discovery added another entry to the long list of places where life has turned up where logic said it shouldn't be. Antarctica is relentless in this way. Every time a scientist looks somewhere new, whether beneath the deepest ice, under the ice shelves, in the subglacial lakes, in the bare exposed rocks of the dry valleys, life tends to show up. Not always, obviously. Sometimes just as a few genetic sequences in a water sample, or a thin biological crust on the underside of a translucent rock. But it shows up. The dry valleys of Antarctica deserve a moment of our attention because they are one of the strangest places on Earth, and they sit in an odd relationship to everything we've been talking about. The McMurdo Dry Valleys are a system of wide, wind-scoured valleys in the Transantarctic Mountains near the Ross Sea coast. They are called dry valleys because, uniquely for Antarctica, they receive almost no precipitation. The mountains surrounding them block the flow of ice from the interior, and the powerful katabatic winds, which are dense cold winds that pour down from the high interior plateau, evaporate any snow or ice that tries to accumulate. As a result, the valley floors are bare rock and gravel, dark-coloured, surrounded by glaciers and ice-covered mountains, but themselves largely free of ice. They look more than anywhere else on Earth like Mars. The similarity is not casual. NASA has used the dry valleys as a testing ground for instruments and protocols intended for Mars missions. The conditions there, extreme cold, intense ultraviolet radiation, minimal liquid water, very low atmospheric humidity, are the closest analogue on Earth to the Martian surface. If you wanted to practice looking for life in an environment like Mars, the dry valleys are where you would go, and life is there. Not abundant, easy-to-see life, but it is there if you know where to look. Inside the rocks themselves, not on their surface but inside the translucent upper millimeters of certain light-coloured rocks, there are communities of microorganisms called endolithic communities. The rock acts as a tiny greenhouse, letting enough sunlight through to allow very slow photosynthesis, while blocking the worst of the UV radiation and providing a slightly more stable temperature than the exposed surface would offer. These organisms grow at a rate that is almost impossibly slow by our standards. Some of them may add a millimetre of biomass over decades. Their entire world is the inside of a rock, and they have been there for who knows how long. In the lakes of the dry valleys, which are permanently ice-covered but contain liquid water below, there are microbial mats, thin layers of microorganisms built up over thousands of years, stratified in layers by chemistry and light availability, surviving in an environment that would kill most living things in minutes. These mats are among the oldest continuously living biological communities on Earth. Radiocarbon dating of the mats in some of the dry valley lakes suggests they have been growing, generation by generation, since the end of the last ice age. 8,000 to 12,000 years of continuous biological growth in a lake whose surface is never free of ice, whose water is just above freezing, whose nutrient input is almost nothing. They survive because they are extraordinarily patient. They grow slowly. They use what little energy is available with an efficiency that is difficult to comprehend. They do not rush. They do not compete in the way we usually imagine competition. They simply persist. There is something almost meditative about the microbial mats of the Antarctic dry valley lakes. They have no plans, no urgency, no awareness. But in their persistence, in their slow building of structure and complexity over thousands of years, there is something that looks, from a distance, like determination. The world is full of quiet persistence that we forget to notice. The slow growth of a crystal in cooling magma, the patient accumulation of sediment on a seafloor, layer by layer, grain by grain. The microbial mats doing the same thing they have done for 10,000 years, with no knowledge that they are remarkable, with no awareness of the ice above them, or the mountains around them, or the fact that somewhere on the other side of the planet, human beings are awake and thinking about them. Let's drift a little further. I want to talk now about something that connects Antarctica not just to our past, but to our present. Something that is happening right now at this moment, while the stars are moving slowly overhead and the night is doing what night does. The ice is changing. This is perhaps the most important fact about Antarctica in our time. The continent we have been exploring tonight, with its hidden lakes and buried mountains and ancient air bubbles and patient, microbial communities, is not static. It is responding to the warming of the global climate in ways that scientists have been watching with great attention and in many cases considerable concern. Not all parts of Antarctica are changing in the same way. East Antarctica, the older, thicker, more stable part, has shown relatively little change so far. Its enormous ice sheet sitting on bedrock well above sea level is deeply stable and would take an almost unimaginable amount of warming to destabilize significantly. West Antarctica is a different story. West Antarctica sits on bedrock that in many places is well below sea level. The ice sheet there is thinner and rests on a more precarious foundation. And in the last few decades, scientists have observed that several of the major glaciers draining West Antarctica have been accelerating, moving more quickly toward the ocean, losing ice faster than new snowfall can replace it. The most closely watched of these glaciers is called Thwaites Glacier. You may have heard it referred to in some news reports as the Doomsday Glacier, which is a name that carries more drama than is quite warranted, but which reflects a genuine scientific concern. Thwaites is enormous. It is roughly the size of Florida, and it is retreating. The ice front is moving backward, further inland, as warm ocean water intrudes beneath the ice shelf and melts it from below. The rate of retreat is not catastrophic in human terms. It is happening over decades and centuries, not overnight. But in geological terms, it is fast. Very fast. If Thwaites were to collapse, not immediately, but over the coming centuries under continued warming, the effect on global sea levels would be significant. Thwaites alone holds enough ice that its complete melting would raise sea levels by roughly 65 centimetres. That's about 2 feet, and it is connected to even larger bodies of ice that could follow if it destabilises. Some scientists estimate that the full collapse of West Antarctica's ice sheet would, eventually, raise global sea levels by 3 to 5 metres. This is not tonight's problem. It is not this century's certainty. The timelines are long and uncertain, and the specific outcomes depend on decisions that are still being made. But the possibility sits there, in the data, in the measurements taken year after year from satellites and ships and ice drilling expeditions. What I find worth sitting with, in a quiet and reflective way, is how this connects to everything else in our story. The ice that has preserved the record of 800,000 years of climate history, that has sealed away ancient lakes and buried mountains and possibly harboured life in its darkest depths, is also, right now, in our present moment, responding to what humans are doing on the surface of the planet. The ice that has been patient beyond all imagination is now, for the first time in its long existence, responding to something that has changed on a very human timescale. Not to the slow drift of continents, not to the gradual shift in the Earth's orbit, not to the long cooling that began 30 million years ago, but to changes that have happened in the last 150 years. There is a kind of meeting happening between deep time and human time, the ancient and the immediate looking at each other across a gap that we're only beginning to understand. Now let me take you to a different kind of place within Antarctica. Not a lake, not a valley, not a glacier face. A quieter place. A place that few people have visited, but which has a particular significance in the long history of Antarctic exploration. At the bottom of the world, at the precise geographic South Pole, there is a research station. It is called Amundsen Scott South Pole Station, named after the two men who first reached this exact point. Roald Amundsen, a Norwegian, who arrived on December 14, 1911, and Robert Falcon Scott, a Briton who arrived about 5 weeks later on January 17, 1912, to find a Norwegian flag already there. The story of those two expeditions is one of the great stories of human endurance and contrast. Amundsen was methodical, experienced, perfectly equipped, and understood the Antarctic environment from years of polar work. He used sled dogs, wore Inuit-style clothing that breathed and insulated correctly, planned his route with precision, and arrived at the pole and returned home without losing a single man. Scott was brave but less well prepared for the specific demands of Antarctic travel. He relied partly on motor sledges that failed, partly on ponies that were unsuited to the conditions, and partly on man-hauling, which means the men pulling the heavy sledges themselves. He reached the pole, and then, on the return journey, he and all 4 of his companions died in a blizzard, just 17 kilometers from a depot of food and fuel that would have saved them. Scott's final journal entries, written in the tent as the storm raged outside and the cold slowly took them, are among the most moving things ever written by a human being in extremity. He wrote about his disappointment, his admiration for his companions, his care for their families. His last written words were, "I do not think I can write more. For God's sake, look after our people." The tent was found 8 months later by a search party, with the 3 men still inside, preserved by the cold, their journals and scientific specimens still with them. The tent was collapsed over the bodies and a cairn was built over it. It is still there, buried now under decades of accumulated ice and snow, slowly moving with the ice toward the sea, which it will reach in many thousands of years. Everything in Antarctica is on a different timescale, even the dead. The South Pole Station today bears almost no resemblance to the tents and sledges of 1911. It is an elevated modern building, designed to sit on adjustable supports so it can be raised as snow accumulates beneath it. Inside, there are laboratories, a gym, a greenhouse, where the scientists grow vegetables to supplement their supply of freeze-dried and canned food, a library, meeting rooms, sleeping quarters, all the necessities of modern life, transported to the most remote and inhospitable location on the surface of our planet. Beneath the station, drilled into the ice, are some of the most sensitive scientific instruments on Earth. There is a neutrino detector called IceCube, which consists of strings of light sensors buried as deep as 2.5 kilometers into the ice. Neutrinos are nearly massless particles produced by cosmic events, supernovae, black hole mergers, the violent processes happening at the centers of distant galaxies. They travel across the universe at the speed of light and pass through almost everything, including the entire Earth without stopping. Almost. Occasionally, a neutrino will interact with the ice of Antarctica and produce a tiny flash of light. The IceCube sensors detect these flashes. By measuring the direction and energy of the detected neutrinos, scientists can trace them back to their source and learn about the most energetic processes happening in the observable universe. So here, in the ice of Antarctica, which we have been treating as a record of Earth's history, there is also a window looking outward. The same ice that contains the air breathed by woolly mammoths is also catching particles fired from galaxies billions of light years away. The ice is a library, and one of the books in its collection is about the universe. There is a thought in that which I find profoundly calming. This single substance, this water frozen into solid form over millions of years, this patient white accumulation at the bottom of our world, is doing so many extraordinary things at once. It is keeping records of the past, it is harbouring possible life, it is responding to the present, and it is detecting messengers from the deepest reaches of space and time, all at the same time, all quietly, all without any drama. That is what Antarctica is, a place of enormous complexity and significance, wrapped in the plainest, most featureless surface imaginable. The white of the ice sheet gives nothing away. You would never guess, looking at it from the surface, that all of this is happening beneath it. And perhaps that is the most Antarctic thing about it. The appearance of emptiness, concealing an interior of immense richness and depth. Let's drift a little further. The dry valleys we visited earlier have another feature worth mentioning. In the largest of them, Taylor Valley, there is a glacier called Blood Falls, and despite the somewhat dramatic name, it is not a violent thing. It is, in its own way, one of the most quietly beautiful mysteries in Antarctica. At the snout of Taylor Glacier, where the glacier's face meets the valley floor, there is a stain, a deep, rust-red stain against the white ice, where a slow trickle of liquid seeps out from within the glacier. It looks, as its name suggests, like blood. But it is not blood, of course. It is water, intensely salty water, rich in iron that has oxidized to a deep red color on contact with the air. The water comes from a small subglacial lake trapped within Taylor Glacier. The lake is extraordinarily salty, roughly 3 times saltier than the ocean, which is why it remains liquid despite the temperature being well below the normal freezing point of water. Salt lowers water's freezing point. The saltier the water, the colder it can get before it freezes. The iron in the water is dissolved from the surrounding rock. In the absence of oxygen and light, certain bacteria have been using iron as their energy source, oxidizing it the same way surface bacteria use sunlight. This process has been going on, scientists estimate, for at least 1.5 million years. When the water eventually finds its way out through cracks in the glacier and reaches the air, the iron is exposed to oxygen and immediately turns red. The result is blood falls, that strange rust-red seep on the white glacier face, looking as if the ice itself is slowly bleeding. It is not bleeding, it is breathing in its own quiet way. Something alive and very old, doing what it has always done, in the dark, in the cold, completely indifferent to the sky above it. That is Antarctica in miniature. Life where you would not expect it, operating by rules you would not have imagined, in conditions that seem wrong for everything living, and yet, life. Now I want to take a step back from the specific and spend a few minutes on the philosophical, not in a heavy or demanding way, just a quiet reflection. When we look at all of this, at the hidden lakes, the buried mountains, the ancient air, the patient microbes, the neutrino detector in the ice, the fossil marsupial in the warm forests, the blood-red seep on a glacier face, what does it add up to? I think it adds up to a picture of a world that is far more layered than it looks. The surface of things is often the simplest part. Beneath almost everything, if you look long enough and carefully enough and with the right tools, there is depth and complexity and history and sometimes life. Antarctica is the most extreme example of this on our planet. Its surface is perhaps the most featureless landscape on Earth. White, flat, uniform. Nothing to distinguish 1 kilometre from the next for hundreds of kilometres in every direction. A surface that tells you almost nothing, and beneath it, everything. A continent's worth of buried geography. Mountains that no eye has seen. Lakes that have been sitting in the dark since before our species existed. Air from a world no human ever breathed. Particles from the far reaches of the universe, detected in the dark and the cold. And possibly, just possibly, organisms that have been evolving in complete isolation for longer than the oldest human civilization is old, by a factor of thousands. If that does not make you feel something quiet and wide and deeply curious, then I don't know what will. The world is richer than we remember, more patient than we are, more layered, more strange, more beautiful in its strangeness than we usually take time to appreciate. And Antarctica, sitting at the bottom of the world in its white silence, is perhaps the clearest reminder of that. We have been travelling together for a long time now, through the layers of ancient ice, past the buried mountains and the hidden lakes, along the subglacial rivers that flow in darkness beneath kilometres of frozen silence. We stood beside the fossil bones of a small, warm creature that lived in forests long vanished. We watched the aurora australis ripple across a sky full of more stars than most people ever see in a lifetime. We found life in places where, by every old rule, life was not supposed to be. And now we begin to turn a corner, not a sharp corner. Nothing in this story turns sharply. Everything here moves the way glaciers move, the way deep time moves, with a slowness that is its own kind of beauty. But we begin here to look at what all of this means, not just as science, not just as geography or biology or geology, but as something that touches the way we think about ourselves and our world and our place in the long story of this planet. We begin, slowly, to look at the bigger picture. But first, let me take you somewhere specific. Somewhere that deserves its own careful attention. Imagine you are on a ship. Not a large cruise ship, not a vessel built for comfort and entertainment, but a research vessel, grey and practical and strong, built to push through sea ice. The ship is called, let's say, after one of the great Antarctic explorers. It smells of salt and diesel and the particular cold wet smell of a metal hull in freezing water. The deck is slippery with frost in the mornings. The crew wears heavy gear constantly. And the view from the bow, from the very front of the ship as it pushes southward, is one of the most arresting things you can see on this planet. the sea ice begins. At first, it is just individual pieces, flat white plates floating on dark grey water, tilted and bumping gently against each other in the swell. Then the pieces get larger. Then they start to lock together, gaps of open water becoming narrower, until the ship is no longer sailing on water at all but pushing through solid ice, the hull groaning with the effort, chunks of ice scraping and crunching along the sides with a sound like a slow avalanche being played in slow motion. And ahead of you, eventually, the coast of Antarctica. From the sea, Antarctica looks like a wall of white rising from the dark water in cliffs of ice that can be 50, 100, 200 meters tall, blue-white at the top, green-blue in the middle, dark, almost navy blue at the waterline where the ice has been shaped by the constant movement of water. The cliffs reflect in the dark sea when the water is calm, so you see the real cliff and its mirror image below, and between them a thin line of water and sky that seems impossibly fragile against all that mass and cold, and the sound. The ice cliffs are not silent. They creak and crack, and every now and then, without warning, a section breaks free, a carving event, and falls into the water with a crash that echoes across the flat grey sea. The wave it creates spreads outward in slow rings, white water and churned ice, and then the sea settles again, and the fallen piece of ice bobs and turns slowly in the water, a new iceberg finding its balance in the world. Icebergs. We should talk about icebergs. Antarctica produces more icebergs than anywhere else on Earth. They're carved from the edges of glaciers and ice shelves, broken off by the movement of the ice and the action of the sea, and they drift northward on the Antarctic circumpolar current, slowly melting as they enter warmer waters. Some of them are enormous, not the irregular, spiky icebergs of the North Atlantic, familiar from paintings and disaster stories, but tabular icebergs, flat-topped, with vertical sides, like enormous pieces of a white table floating in the sea. The largest iceberg ever recorded was called B-15. It broke off from the Ross Ice Shelf in March 2000. It was approximately 295 kilometers long and 37 kilometers wide. Its surface area was about 11,000 square kilometers, roughly the size of Jamaica. It weighed somewhere in the region of 3 billion tons. It floated in the Southern Ocean for years, slowly drifting north, gradually breaking into smaller pieces as currents and waves worked on it. Pieces of B-15 were still being tracked by satellites more than 2 decades after it calved. The last fragments drifted far north before finally melting away. 3 billion tons of fresh water, slowly released into the Southern Ocean over 2 decades. Every iceberg is a piece of the ice sheet's long memory, released into the moving world. It was once snow, fallen on the interior of Antarctica, compressed over centuries into ice, carried slowly outward by the flow of the glacier, and finally broken free into the sea. From the moment the snowflake fell to the moment the last sliver of iceberg melts into the ocean, the journey might take tens of thousands of years. Water that fell as snow before any human civilization existed, finally returning to the ocean in our lifetime. There is something in that. Something about cycles and returns. Something about how nothing is really lost, only changed and moved and eventually returned to its original form. The water that was once snow becomes ice, becomes iceberg, becomes ocean, becomes cloud, becomes rain, becomes snow. Again, somewhere, sometime in the long turning of the world's great cycles. Antarctica sits at the centre of one of the most important of these cycles, the cycle of water, the cycle of cold and warmth, the cycle of ice ages and interglacial periods that has been running for millions of years, shaping the world in ways that ultimately shaped us. Let's think about that for a moment. The ice ages. You have heard the term. You know in general that there have been periods in the past when the Earth was much colder, when great ice sheets covered large parts of North America and Europe, when sea levels were lower, and the landscape looked completely different from how it looks today. The last ice age peaked roughly 20,000 years ago, when ice sheets covered Canada and much of northern Europe and extended well down into what are now temperate zones. But the ice ages are not a single event. They are a rhythm, a long repeating pulse of the planet driven by subtle variations in the Earth's orbit and the tilt of its axis, which change the amount and distribution of sunlight reaching different parts of the planet. These orbital variations, worked out mathematically in the early 20th century by a Serbian scientist named Milutin Milankovic, create cycles of roughly 20,000, 40,000, and 100,000 years. The Milankovic cycles don't directly cause ice ages by themselves, they trigger feedbacks. When slightly less sunlight reaches the high northern latitudes in summer, snow from the previous winter doesn't fully melt. It persists into the next winter, and more snow falls on top of it. As the ice sheet grows, it reflects more sunlight back into space, which cools the planet further, which allows more ice to grow. And as the ice grows, the carbon dioxide in the atmosphere decreases, because the cold and the changing ocean circulation affect the way carbon cycles through the system. The Earth cools, the ice age deepens, then, eventually, the orbital cycle turns. Slightly more sunlight reaches the high latitudes. The ice begins to melt at its edges. The ocean circulation changes. Carbon dioxide rises. The planet warms. The ice retreats. This has happened over and over with variations for at least the last 2.5 million years. Ice age and warm period, glacial and interglacial, the Earth breathing in and out on a timescale of tens of thousands of years. And the record of all of this is in the ice of Antarctica. We said earlier that the ice cores go back 800,000 years. In that span of time, there have been roughly 8 complete cycles of glacial and interglacial conditions. Each one is visible in the ice, in the chemistry, in the isotopes of oxygen and hydrogen that record the temperature, in the carbon dioxide trapped in the ancient air bubbles. The ice core record shows something striking. Over the past 800,000 years, carbon dioxide concentrations in the atmosphere have fluctuated between about 180 parts per million during the coldest parts of ice ages and about 280 parts per million during the warmest interglacial periods. That range, 180 to 280, is the natural range within which our planet's carbon cycle has operated for nearly 1 million years. The current concentration of carbon dioxide in the atmosphere is over 420 parts per million. It has risen from 280 at the start of the Industrial Age to its current level in about 150 years. That is not just above the range seen in the ice core record. It is outside the range entirely, higher than at any point in at least 800,000 years, and quite likely for several million years before that. I am not going to dwell on this in a way that creates anxiety. That is not what this story is for. But I think it is important to say calmly and clearly, because it is the truth, that what the ice cores tell us about the present is as significant as what they tell us about the past. They are not just a history book, they are also a measurement tool, and what they are currently measuring in the context of everything they have recorded before is something unprecedented in the long record they contain. The Earth has been warmer than it is now in its very deep history before the ice core record begins. It has seen higher carbon dioxide levels in the ancient geological past. None of this is permanently catastrophic for the planet itself. The planet will continue. Geologically, chemically, physically, the Earth will be fine. The question is more specific than that. The question is what happens to the particular arrangement of climate and geography and biology that has supported human civilization for the last 10,000 years in the era scientists call the Holocene. That arrangement was not an accident. It was the product of a very specific and relatively stable set of conditions, and it is those conditions that the ice cores now show us moving outside their familiar range. Antarctica holds the memory of that range. The ice remembers what normal looks like, and in remembering it, it also, quietly and without judgment, shows us how far from it we have moved. Let's drift a little further. I want to come back now to something we touched on earlier, the question of life. Not the microbial life in the ice or the subglacial lakes, though we will return to that. I want to talk about Antarctica's relationship with the question of life on other worlds. This is not speculation without grounding. This is a line of scientific thinking that has been developing seriously for decades, and that has led to real research programs, real funding, and real discoveries. The logic goes like this. If life can exist in the subglacial lakes of Antarctica, in complete darkness, under kilometers of ice, isolated for millions of years, running on chemistry rather than sunlight, then life might also exist in similar environments elsewhere in the solar system. And there are environments elsewhere in the solar system that look remarkably similar to what lies beneath the Antarctic ice. Europa. Europa is one of the 4 large moons of Jupiter. It is roughly the size of our moon. From the outside, it looks like a cue ball, smooth and white and slightly bluish, covered in a network of reddish-brown cracks and lines. There is almost no topography. No mountains, no craters of any size, because whatever craters might have formed have been erased. The surface is ice, and beneath the ice of Europa, strong gravitational and magnetic evidence suggests there is a liquid water ocean, not a small pond, not a subglacial lake the size of Lake Vostok. A global ocean completely encircling the Moon beneath an ice shell estimated to be somewhere between 10 and 30 kilometres thick. The ocean is thought to be in contact with Europa's rocky seafloor, where tidal heating generated by the gravitational squeezing of the Moon as it orbits Jupiter in a slightly elliptical path may create something analogous to the hydrothermal vents we find on Earth's ocean floor. Warm water, mineral-rich, possibly turbulent, rising from the rock below. The conditions for life as we understand it after the discoveries in Antarctica and in deep-sea hydrothermal vent ecosystems, the conditions are not obviously absent on Europa. There is liquid water, there may be chemical energy sources. The ocean has been there for billions of years, more than enough time for life to have started if the conditions were right. We have not visited Europa's ocean. We have never drilled through its ice. We have only observed it from spacecraft flying past or orbiting overhead. But NASA's Europa Clipper mission, launched in 2024, is on its way to the Jovian system and will make dozens of close flybys of Europa, measuring its ice shell, its ocean, its chemistry, and its geological activity in more detail than ever before. The results will shape our thinking about Europa's habitability for decades. There is also Enceladus, a small moon of Saturn, which has been observed actively venting water vapour and ice particles from cracks near its south pole. Clear evidence of a subsurface liquid ocean making direct contact with space through these vents. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, flew through these vents and detected complex organic molecules, hydrogen, and silica nanoparticles consistent with hydrothermal activity on the seafloor. And there is Titan, another moon of Saturn which has lakes and rivers and rain, not of water, but of liquid methane, a world where the chemistry of life, as we understand it, would have to work with methane as a solvent instead of water. Whether life can do that, whether the basic chemistry of biology can operate in liquid methane at minus 179 degrees Celsius is a genuine open question. What Antarctica has done for all of these discussions is expand the range of what we consider possible. Before the discoveries in the dry valleys and the subglacial lakes and the deep-sea hydrothermal vents, the implicit assumption in most thinking about extraterrestrial life was that life required conditions reasonably similar to the surface of the Earth. Moderate temperature, liquid water, sunlight, stable chemistry. Antarctica and its underground worlds dismantled that assumption one discovery at a time. Now the question is not whether life can exist in extreme conditions. We know it can. The question is how extreme is too extreme? Where is the edge? And every time a new discovery pushes our sense of that edge a little further out, every time a microorganism is found somewhere more extreme than the last, the range of places where we might look for life in the universe gets a little wider. Antarctica is the laboratory where we learn what life is capable of. And what it has taught us so far is that life is capable of far more than we imagined. Let's take a slower turn now. There is a particular quality of light in Antarctica that I have not described yet, and I want to give it its proper attention before we move on. It is the light of the Antarctic summer, at a time of day that doesn't quite map onto ordinary experience because in summer, every hour has roughly the same quality of light. The sun is always at a low angle, always skimming the horizon rather than rising overhead. So the light is always that particular golden horizontal light that on most of the planet you only get for a few minutes at sunrise or sunset. In Antarctica, that light lasts all day, for months. Everything it touches is transformed by it. The ice glows, not just reflects, but seems to emit light from within, a warm amber and gold that you would not expect from something cold and white. The shadows are long and blue, running across the snow in directions that change slowly as the sun circles overhead without setting. The sky at the horizon can be every shade between deep violet and warm orange simultaneously, a gradation of colour that painters struggle with and cameras cannot quite capture. Scientists and support staff who spend summers in Antarctica often talk about this light as one of the most psychologically powerful things about the place. It does something to the mood. It makes everything feel slightly unreal, slightly outside of ordinary time, as if you are living inside a painting or inside a very long and very beautiful dream. Some of them describe a feeling of being watched by the landscape, not in an uncomfortable way, more in the way that a very old forest sometimes makes you feel watched, because everything in it has been there far longer than you have, and its attention, if you want to call it that, is of a different order than human attention. Slower, more patient. Not interested in you specifically, but aware in some proverbial way of the fact of presence. Antarctica has that quality very strongly. The landscape is so old, so vast, so unchanged by human activity compared to everywhere else on Earth, that standing in it feels like standing in the gaze of geological time itself. It is not comfortable in the ordinary sense, but it is profound, and profundity has its own kind of comfort. Several Antarctic researchers have described the experience of returning home from a long deployment there as disorienting in a very specific way. Not because home is unwelcoming, but because the pace and noise and density of ordinary life feels suddenly strange after months in a place of such slowness and space. The traffic, the crowds, the constant stimulation, the speed at which everything happens. It takes time to readjust, to come back down from the long, deep quiet of the ice. Some of them never fully lose the sense of perspective that Antarctica gives them. The awareness that the world is very old and very large, and that the things that feel urgent in ordinary life are, from the perspective of geological time, barely perceptible. That awareness can be a gift, a kind of internal spaciousness that stays with you long after you've left the white continent behind. Let's drift a little further toward the final chapter of what we'll explore in this part of the journey. We have been inside the ice, beneath it, along its edges, in its hidden lakes and on its ancient rock. We have talked about what the ice remembers and what it harbours and what it is doing right now as the climate changes. We have visited the people who spend their lives studying this place and the feeling it gives them. Now I want to bring all of that together and ask one more question. A question that is both scientific and something more than scientific. What does it mean that there is a place on Earth that is essentially unexplored? We live in an era when it is easy to feel that everything has been found. Every mountain climbed, every ocean crossed, every forest mapped and measured. The satellites above us can read the license plate on a car from space. We have images of almost every square kilometre of the Earth's surface available on our phones. And yet, beneath the ice of Antarctica, there is a continent we have never seen. The actual surface of the rock under the ice sheet has been mapped only by the faint echoes of radar waves. The mountains there have no photographs. The valleys have no human footprints. The riverbeds of rivers that flowed 30 million years ago lie in their original shapes, exactly as they were the day the ice covered them, unseen, unvisited, unknown in any direct sense. The subglacial lakes have barely been touched. Of the 400 or more that are estimated to exist, only a tiny handful have been approached at all. Lake Vostok has been drilled. A smaller lake called Willen's Ice Stream Subglacial Lake was directly sampled by a team of American scientists in 2013, using a hot water drilling technique that melted a borehole through 800 meters of ice in about a day. That team found microbial life, not as a possibility but as a direct measurement. Living cells in the water of a lake that had been sealed under the ice for somewhere between 10,000 and 100,000 years. 10,000 years is not as long as Vostok, but it is still far longer than any human civilization, and the organisms found there were alive, doing whatever it is that organisms do at the microbial level, processing chemicals, reproducing, existing. And the lake was connected to the subglacial water system, to the rivers and channels that link Antarctica's hidden lakes together, meaning that wherever those water pathways go, life potentially goes too. The exploration of this hidden world has barely begun, and unlike the exploration of the surface of Mars or the moons of other planets, which requires sending spacecraft across hundreds of millions of kilometers of space, the exploration of Antarctica's subglacial world requires traveling to a place we can already reach, drilling through a material we know how to drill through, and looking at what is already there. It is close, it is achievable, and it is one of the last genuinely unexplored frontiers on our own planet. There is a particular kind of excitement in proximity. When something extraordinary is not out among the stars but here, on our own world, reachable by ship and plane and drill, it feels both more immediate and, in a strange way, more humbling. The universe is vast and unknowable, but this we could actually go and look at. This is not a distant hypothesis. It is under our feet, in a manner of speaking, just very, very far south, and it is waiting. The ice does not hurry. The hidden lakes do not hurry. The buried mountains have been waiting since before our species existed, and will still be waiting long after we're gone, unless we go and find them first. There is something beautiful in that waiting. Something that feels, in the deep night of this hour, like an invitation. Not an urgent one, not a demanding one, just a quiet, patient, open invitation from the oldest and coldest and most silent part of our world. Come and see. When you're ready, take your time. We have been here for 30 million years. We are not going anywhere. We are near the end now, not the end of Antarctica's story. That story has no end, or at least none that falls within the reach of human time. The ice will still be doing what ice does long after every word spoken tonight has dissolved into silence. The hidden lakes will still be full and dark and patient. The buried mountains will still be waiting in their frozen stillness, undisturbed, unmoved, exactly as they were on the day the world covered them. But we are near the end of our journey through it, and I want to take this last part slowly, more slowly than anything before it. I want to let the ideas breathe and spread out, and settle the way snow settles, softly and without rush, covering everything in a quiet layer of white. So take a breath now, a slow one. Let your chest rise and fall at whatever pace feels natural. Let the weight of wherever you are press gently back against you. The bed, the couch, the floor, the chair, whatever is holding you up right now, let it hold you completely. You don't have to hold yourself up at all. We have covered a great deal of ground tonight. We have walked through the compressed layers of 800,000 years of atmospheric memory. We have stood beside lakes that have not seen sunlight since before our earliest ancestors existed. We have traced the rivers that flow in eternal darkness under kilometers of frozen silence. We have found life in the hardest places imaginable, in rocks, in glaciers, under ice shelves, in water so cold and so salty that it should not, by any ordinary logic, be able to support anything living. And we have asked, gently and without demanding any particular answer, what all of this means. Tonight, in this last part, I want to explore that question one final time. Not to resolve it, not to wrap it up neatly, but to let it open the way a flower opens, slowly, in the direction of light. Let's begin at the very beginning of Antarctic science, not 1820 when the first human eyes saw the continent through fog and spray. Earlier than that, in the place where the idea of Antarctica was born before anyone knew it was real. The ancient Greeks, as we mentioned at the start of our journey, believed there must be a great landmass at the bottom of the world. They called it Terra Australis Incognita, the unknown southern land, and their reason for believing in it was elegant and mathematical. The northern half of the world was dominated by a great landmass, the continents of Europe, Asia, and Africa. For the world to be balanced, they reasoned, there must be a corresponding mass in the south. They were right. Not because of the mathematics of balance, which is not actually how planetary physics works, but they were right anyway. There is a great southern landmass. It is larger than they probably imagined, and it is, as they suspected, a world unto itself. I find something moving in that. The Greeks couldn't see Antarctica. They had no ships capable of reaching it, no instruments to detect it, no evidence in any direct sense. They inferred it from reason alone, from the desire for the world to make sense, to be balanced, to have a kind of symmetry that satisfies something deep in the human mind. And they were right. There is a lesson in that about how human curiosity works. We often know, or at least sense, that something is there before we can prove it. Before we can measure it or see it or hold it in our hands, the intuition comes first. The evidence comes later, and when the evidence finally arrives, it is almost always stranger and richer than the intuition imagined. That is the story of Antarctica in miniature. People believed in it before they found it. When they found it, they thought it was just ice. When they looked beneath the ice, they found mountains and lakes. When they looked in the lakes, they possibly found life. When they looked at the life, they started thinking about other moons, other worlds, other oceans under other ice in other parts of the solar system. Each layer of understanding reveals a deeper layer of mystery, and the mystery is never frightening. It is always, at the bottom of it, an invitation. Come and see what else is here. Imagine you are lying on your back on the surface of the East Antarctic ice sheet. It is summer. The sun is circling low overhead, never setting, casting its long amber light across the flat white plain. The ice beneath you is 4 kilometers deep. You are lying, in a sense, on top of the deepest library in the world. Below you, in order of depth, are the following things. The first few meters are recent snow, loose and light and full of air, still not fully compressed into ice. The snow that fell last winter, the winter before, the past few decades of Antarctic snowfall layer upon layer. Deeper, maybe 100 meters down, the ice is properly dense, ancient. the air bubbles beginning to be compressed almost to the point of disappearance. This ice is several thousand years old. It was falling as snow around the time that the great Bronze Age civilizations were rising in the Middle East, when the first cities were being built in Mesopotamia and the Nile Valley. At 500 meters, the ice is roughly 20,000 years old, the last glacial maximum. The world was much colder then. Great ice sheets covered Canada and Scandinavia. Sea levels were over 100 meters lower than they are today. The English Channel didn't exist. You could walk from Britain to France. Humans were living in small nomadic groups, following herds of animals across landscapes that no longer exist in their current form. At 1,000 meters, the ice is perhaps 80,000 years old. Modern humans had spread out of Africa by this point, but barely. The world's human population was perhaps a few 100,000 people, scattered across the continents in tiny groups, leaving almost no trace. At 2,000 meters, the ice is several 100,000 years old. There were no modern humans. The species that eventually became us was still evolving. The world was in the middle of one of its long glacial cycles, cold and dry and swept by enormous dust storms that left their signatures in the ice as thin, pale layers. At 3,000 meters, the ice is approaching the limit of the longest records we have. 800,000 years. A world that no human eye ever saw. A world that our kind was not yet part of. A world that was doing exactly what it had always done. Cycling through its rhythms of cold and warmth, ice and thaw, with complete indifference to the creatures that would eventually look back at it and try to understand. And at 4 kilometers, at the very base of the ice sheet, where the ice is so old and so compressed that it barely behaves like ordinary ice anymore, where the pressure from above is so immense that the ice deforms and flows like very slow putty, where the heat from the earth below just barely keeps the very bottom layer from freezing solid to the rock, there is water. And in that water, there may be life. You are lying on top of all of this, 4 kilometers of time beneath you. The entire history of human civilization compressed into the upper layers, barely visible in the great depth of what is below. And at the bottom, in the dark, something patient and alive and completely unknown to us. What do you feel lying there? I think I would feel very small, but not uncomfortably small. The kind of small that is actually a relief. The kind of small that reminds you that you are part of something incomprehensibly large and old, and that being part of it, even briefly, even in the thin recent layer at the very top, is not nothing. It is something. It is quite a lot, actually. We spend much of our lives feeling that our smallness is a problem, that we are not big enough, not significant enough, not lasting enough, that the brevity of a human life, the narrowness of a human perspective, the limits of what one person can know or do or understand, are somehow failures, inadequacies, things to be overcome or at least not thought about too directly. Antarctica suggests a different way of seeing it. In Antarctica, smallness is simply accurate. It is not a failure, it is a description. The continent is old and we are young, the ice is deep and we are thin, the time is vast and we are brief, and none of that is a tragedy. It is just the shape of things. It is the correct proportion of a human being in the context of the world's actual dimensions. And within that correct proportion, there is a great deal of room for wonder, for curiosity, for the kind of quiet, persistent investigation that leads a team of scientists to spend 20 years carefully drilling toward a lake they cannot see, driven by nothing more urgent than the desire to know what is there. That is one of the most distinctly human things I can think of. The willingness to do patient, difficult, painstaking work in pursuit of knowledge that may not yield any immediate practical benefit. Not because someone told you to, not because there is money in it, but because the question is beautiful and the world deserves to be understood. Let's drift a little further. There is a field of study that has grown substantially in recent decades called astrobiology. It is the science of life in the universe, and it sits at the intersection of astronomy, biology, geology, and chemistry. Astrobiologists study how life begins, what conditions it requires, where in the universe those conditions might exist, and how we might go about detecting it if it does. Antarctica features heavily in astrobiology, not just as an analogue for other icy worlds, though it is that, but as a place where the fundamental questions about life's limits are being actively tested and answered. The central question of astrobiology is deceptively simple. Is life on Earth a fluke, a singular improbable event that happened once and will never happen again anywhere else? Or is life something that the universe produces naturally given the right conditions, the way crystals form naturally given the right chemistry, the way stars form naturally given the right density of gas and dust? The discoveries in Antarctica, and in the deep oceans, and in volcanic hot springs, and in the permafrost of Siberia, and in the acidic lakes of volcanic craters have pushed scientific thinking steadily toward the second option. Life, it turns out, is not fragile. It is not limited to the narrow band of comfortable conditions we find on the surface of the temperate Earth. It is persistent and inventive and capable of adapting to conditions that would have seemed 50 years ago simply incompatible with biology. If life is this hardy on Earth, if it can be found in frozen lakes and volcanic vents, and the inside of rocks and the bottom of glaciers, then the probability that it has arisen somewhere else in a universe with hundreds of billions of galaxies, each containing hundreds of billions of stars, many of them with planets, many of those planets possibly harbouring liquid water, becomes harder and harder to keep low. We have not found extraterrestrial life, not yet, not in any confirmed, unambiguous way, but the search is no longer the long shot it once seemed, and Antarctica, quietly, at the bottom of the world, in its laboratories of ice and darkness, is one of the main reasons why. The ice teaches us that life is older and tougher and more creative than we thought. That lesson reverberates outward, far beyond the white shores of the continent, all the way out to Europa and Enceladus and the exoplanets orbiting distant suns, all the way out to the edge of what we know and the beginning of what we are still learning. Now I want to take you somewhere that is not geological or biological, somewhere a little more personal. Think about the feeling you get when you look at something very old. Not just old in the human sense, not an old building or an ancient artifact, but old in the geological sense. A rock formation that is 1 billion years old, a fossil from 500 million years before the present, a piece of meteorite that formed in the early solar system 4.5 billion years ago. There is a particular kind of silence that comes with that kind of age, a quietness that is not merely the absence of sound, but the presence of something, a depth, a gravity. The sense that this object has been here for so long, has witnessed so much change, has outlasted so many things that seemed permanent at the time, that it carries a kind of weight that ordinary objects don't have. The ice of Antarctica has that quality. So do the mountains buried beneath it. So does the water in Lake Vostok sitting in its dark basin for 25 million years without seeing the sky. There is a presence to that age, a quality of having endured. And when you encounter something that has endured for that long, something happens to the urgency of your ordinary life. The things that felt pressing, the deadlines and the worries and the minor frustrations, they don't disappear, but they become smaller. Not unimportant, but correctly scaled. You can see them for what they are, which is temporary concerns in a very long story that was happening long before you arrived and will keep going long after you're gone. That rescaling is not depressing. It is a gift. It creates space, room to breathe, permission to be exactly as small and brief and passing as you actually are, without apology and without distress. Antarctica gives that gift to everyone who learns its story. You don't have to go there. You don't have to stand on the ice or feel the cold or see the aurora. The gift is available here, now, in a warm room at the end of a long day, just from knowing that the place exists and understanding what it holds. The world is much older than your worries. The ice remembers what the sky was like long before there was anyone to look at it, and you, lying there in the dark right now, are a brief and luminous part of the same story that the ice has been telling for millions of years. Let's take our time with the last few pages of tonight's journey. There is a concept in Japanese called mono no aware. It translates roughly as the pathos of things, or the gentle sadness of passing things. It is the feeling you get when you watch cherry blossoms fall, or when you see the last light fade from the sky at dusk, or when you finish a book you loved and close the cover for the last time. It is not sharp sadness. It is more like a bittersweet tenderness toward the fact that beautiful things are temporary, that their temporariness is part of what makes them beautiful. Antarctica carries mono no aware in a very large and very quiet way. The ice is melting in some places faster than it has in a very long time. The glaciers are retreating. The ice shelves are thinning. The permafrost around the edges of the continent is softening in the warming summers. These changes are real, and they are being measured, and they carry implications for the future that scientists continue to study with great care and seriousness. And at the same time, the ice that remains is still doing everything it has always done. still preserving its records, still covering its lakes and mountains, still catching neutrinos from distant galaxies, still being the coldest and strangest and most patient place on Earth. There is a tenderness in holding both of those things at once, the awareness of change and the appreciation of what is still there, the acknowledgement of loss and the gratitude for what persists. That is not resignation. It is not giving up. It is simply the honest emotional response to a world that is always changing and always still, here at the same time. A world that has been changing for 4 billion years and will keep changing for billions more. A world that does not require our permission to change or our approval or even our understanding. But that becomes somehow more itself when it is understood, when someone pays attention to it, when someone lies awake at night and listens to a story about it and lets the wonder of it settle in. You have done that tonight. You have paid attention. You have travelled a very long way in imagination and in understanding to one of the strangest and most extraordinary places on our planet. You have walked through compressed time, breathed ancient air, stood beside lakes that no sunlight has ever touched, and asked the question that all good science and all good wondering eventually arrives at. What else is there? The answer Antarctica gives, with its hundreds of hidden lakes and its buried mountains and its ancient records and its patient microbes, is always the same. More. There is always more. More than you knew before you started looking. More than anyone imagined before the tools existed to see it. More than the maps show. More than the surface reveals. More than a single human life can hold, or a single discipline can contain, or a single expedition can uncover. The world is inexhaustibly deep, inexhaustibly old, inexhaustibly strange and rich and layered. And that, perhaps, is the most comforting thought of all. We will never run out of things to wonder at. We will never reach a point where everything has been understood and there is nothing left to discover. The hidden lakes of Antarctica alone could occupy scientists for centuries and still not yield all their secrets. The question of what is alive down there, in that dark and pressured and ancient water, may take generations to answer fully. And beyond Antarctica, there are the moons of Jupiter and Saturn, with their own ice-covered oceans and their own unanswered questions. There are the exoplanets, thousands of them now catalogued, orbiting stars across the galaxy, some of them possibly harbouring liquid water, some of them possibly harbouring whatever it is that liquid water, and the right chemistry eventually produce if given enough time. There is so much that we do not know yet, and the not knowing is not a gap or a failure. It is the space where the future happens, the open territory into which all future discovery will travel. Antarctica taught us that. More than any other place on Earth, Antarctica showed us that the world we thought we knew had another world inside it, and that the world inside that world had another one inside it too. It always goes deeper. It always goes further back. It is always at the bottom more mysterious and more alive than anyone expected. Let the sound of wind across a white plain come to you now if you can imagine it. That low, continuous murmur. That note held for a very long time on a very deep instrument, the voice that has been speaking since long before you arrived. Let the image of the aurora come too, those green and violet curtains rippling in silence across a sky so full of stars that the darkness itself seems to glow. Let it fill the space behind your closed eyes, or the quiet interior of whatever rest you have found tonight. Let the blue of deep ice be the last colour you hold, that impossible, luminous blue, not cold, not harsh. Just deep and clear and ancient, lit from within by the memory of light that fell as snow on a world no human ever walked through. That is Antarctica, holding everything, keeping everything, patient and cold and full beneath its silence, of more life and more time and more mystery than we will ever fully reach. And here, at the end of this long and quiet journey, I want to say something simple. Thank you for travelling with me tonight, through all of it, through the ice and the darkness and the hidden water and the ancient air, through the buried mountains and the patient microbes and the vast cold question of whether something is alive in a lake that has not seen the sky in 25 million years. You came all the way to the bottom of the world and back, that is something. The world is strange and old and full. You are here in it briefly, and that is not a small thing. It is exactly the right size for what it is. The ice is still there, right now, while you're wherever you are, covering its secrets, keeping its records, waiting with the particular patience of something that has already waited longer than we can truly imagine. The world turns slowly, and so do we. And now, at last, the story grows quiet. Like the last light going soft on a white plain, like snow falling on water without a sound.